Hi everyone, I'm Shamsher Ansari. I'm a group product manager at NeevCloud, and I think we are building a lot of products and we are launching a couple of products today. One of them is inferencing engine, AI inferencing, and I think there is no other person than talk about Prasad about this inferencing capability. So here we have a Prasad from Red Hat. So why don't you introduce yourself?
Hey Shamsher, thanks for having me. So my name is Prasad Mukherjee. I'm a specialist solution architect with Red Hat. I've been with Red Hat for long. It's a long time Red Hat I'm known to. Right now what I'm focusing is that how we can reduce the cost per token by using the optimized inference set. And this is where I talk about the vLLM.
Yeah, perfect. So I want to understand, so we are also launching one product called AI inferencing today. And I think we are also using vLLM, definitely. And you've been working on vLLM for quite some time, and then you're also talking to a lot of customers outside India. I think I've seen you've traveled to Singapore, Malaysia, and other places. So what's the current market that you see with AI inferencing today, and how it's expanding with the different customer bases?
Okay, so how I see at an inference is that when it comes to the large language model, Gen AI, open weight model, you have two streams. One is the training. I often call the training as a capex. You have to invest in the
a lot of money.
Skills, you have need models, and then you need the large number of GPUs and all those things. The inference is OpEx, okay, where you leverage that inference to power your application.
That's true.
Inference is linearly increased with number of users connecting.
That's true.
80% of workload of Gen AI would be inference. And that's the trend. The another thing on the inference is that the state of the models that we see in the open source community, those are really very capable these days. Like you don't need to go into the fine tuning and all those things. You just do the data augmentation. When you do the data augmentation and connect that with the inference, you will be quickly able to build that use case. So inference again will become very critical. What I see is that most of the organizations and the lot of communities with whom I am in talk, they are saying that the GPU investment that we are doing or the AI investment that we are doing, we are focused on how we can optimize the
inferencing.
Okay, because we are generating the token. That's the end. It will be token factory for me.
That's true.
And for the token factory, how I can reduce the cost per token is very important for us. This is where the inference optimization.
Yeah, so I like the word you say, cost per token, because ultimately not everyone can train the model. Only hyperscalers and big companies, they are doing these things, right? And like you said, it's a capex, requires a lot of huge upfront investment. You need at least 60,000 or 1 lakh GPUs to train a small models or large language models, right? And definitely not everyone can do it. So you also rightly mentioned, when we were building this AI inferencing capability, we found that 80% of the market today is mostly focusing on inference, right? And 20% is the model training, right? So we have a lot of opportunity on the inferencing side, right? So I want to understand how vLLM is making LLM efficient, like LLM serving efficient, right? Because I've seen a couple of other providers, but right now, based on the community that I've seen for vLLM, and we have been trying that a lot of places. So I want to understand how vLLM is making this LLM serving efficient.
Thanks for asking that question. Let me start with the V. What is a V in the vLLM?
I see.
V refers to the virtual. It's not a virtualization. It's a virtual memory. Okay. So what is happening in the Gen AI space? You need the AI accelerators. Those will be the GPUs or TPU. Inside the AI accelerator, what you have is the arithmetic logic unit. Those are the ports. You will have thousands of ports, and then there is a limited high bandwidth memory.
I see.
High bandwidth memory, we need to utilize that properly, efficiently. The vLLM is focusing on that part. So when it comes to the memory, any application, even for the main memory that we see in our systems, there are two ways we can access the memory. One is the contiguous memory access, non-contiguous. If you do the contiguous memory access, we'll get into the fragmentation. We'll have a lot of memory available, but the application will not be able to allocate that. Same goes with the GPU memory. It's a high bandwidth memory, very precious resource, very expensive resource. We have to manage that properly. For that works vLLM, there are two innovations. One is page attention. I talk about the page attention in every discussion when we talk about vLLM. Because page attention, I would say, is a breakthrough. Because without page attention, you'll have a lot of memory wastage.
Yes.
With a page attention, it's a simple. I mean, in Linux, we have been doing the paging since a long. And that's why Linux is known for highly optimized when it comes to the memory management. We are applying the same concept for the GPU memory. So page attention. The second thing is a continuous batching without waiting for the batch to complete, fill, and then go for the process.
That's true.
We are doing the continuous batching to the vLLM. These are the two things which optimize your inferencing. And those are the key innovation that I would say introduced by the vLLM. On top of that, there are a lot of other things. Like I usually talk about the OpenAI API specification that vLLM support. Because if I'm serving a model, let's say
it should be compatible with OpenAPI.
We need some standardization. I can't say that this is my new way to interact with the.
That's true.
People are familiar with the OpenAI API specification. Let's use that. That's the third thing about the vLLM. So it's a page retention, continuous batching, and the support of widely adopted API specification, that is OpenAI.
So if I understand correctly, it's basically what we have done at the OS layer. That is something vLLM is bringing that to a GPUs.
You are on the spot. So that's what we are doing with the vLLM for the accelerated computing. So nowadays we are talking about the parallel computing, not the sequential computing. Parallel computing, you have the higher bandwidth memory. You are applying the same
concept,
innovation, why the Linux is stable, all those things.
That's true.
For the
So I've also seen that vLLM is a heavy user of KV cache. Right?
Yes.
So ultimately, this HBM memory that you mentioned, it works at the same layer. So I want to understand how vLLM is making use of KV cache to make the LLM serving efficient.
Okay, so KV cache is an essential component when it comes to the inferencing of any GenAI model, be it a vision model, voice capability, or whatever model it is there. KV cache will save your redundant computing.
I see.
Okay, so it is
recomputation is not required basically.
You don't need to, okay, but it will require a lot of memory.
I see.
Okay, so the first thing what we are doing, we are using paged attention to save the memory or that KV cache properly. Second thing is that we also have something called KV cache quantization. Okay, you quantize the KV cache. That means you require less number. So KV cache is again attention mechanism. You trigger the attention mechanism. At the end, you get the query key value. You need a space to save that
definitely
attention, and that's the GPU memory. How you can optimally use that GPU memory again. It comes back to the page attention.
Yeah. So what's the quantization that normally customers prefer when it comes to vLLM? Is it like 16-bit or 8-bit?
It depends on the GPU that is being used.
Okay.
If it is a Blackwell series, I always recommend my set of customers or users to go with something called NVFP4.
Okay.
That is coming
specifically for NVIDIA GPUs.
Yes, for the NVIDIA. But other than that, more than the precision point, you need to look at what is the framework that was used in order to quantize the model. So when it comes to the quantization, we mostly talk about the weight quantization.
Right.
That's great. I mean, it will help you to save the memory that is required in order to load the model weight. But in runtime, more than model weight, where your memory is going, it's going in the KV cache.
That's true.
Activation.
That's true.
How we can do the activation quantization. But again, which precision point to use, that depends on the GPU.
Yeah.
Start with the int 8, FP4, FP8, and then if you are using the NVIDIA, go with NV4.
NV4. Yeah, I think they have recently introduced it, or I think a year ago or something.
So that is, I mean, recent with the launch of the Blackwell.
Yes.
They were working on it. Right now, it's a mainstream. There are very good result of, because if I'm doing the quantization, what I will look is how I can preserve the accuracy.
That's true.
If I'm not preserving the accuracy, there's no use of that quantization. Even if I go to the quantization FP1 or int1, and if I'm not doing that quality work, it is not used. So NVIDIA, what I liked about them, when it comes to the quantization of this model, the quantization, the NV FP4 is low precision, and it will
also save a lot of memory.
It will save them.
In terms of saving those things.
Compromise on the quality.
Yeah, that's the good part. Because people generally say when you quantize a lot, when it comes to a lower precision bits, then the quality of the output will suffer. So I think the NVIDIA is taking care of that with NVFP.
Absolutely.
Yeah, perfect.
Another thing that I want to quickly talk about is the vLLM, because we talk about the inference, and I just want to connect that with the analogy where I can take the example of web development.
I see.
There are the developers who develop the web page on their laptops. They use latest technology like a CSS, Node.js. But at the end, when their application is ready, what they need the web server.
That's true.
Why web server is required? Because they have to serve that web page to thousands of users.
Without that, it's of no use.
No use of that.
That's true.
If you apply the same analogy with the model,
right,
you have pre-trained model which you can download from the Hugging Face, or you can fine-tune the model. Small language model, you have your data set, you find, okay, your fine-tuning is done. Now you want to monetize that. You want to operationalize.
That's true.
Or to take the advantage of that model.
Yeah.
What comes into the picture? Inference. Serve that model. And this is where you need the optimization.
That's true.
Again, 80% as you said,
right.
We have to focus on that.
Yeah. So how do you see the community building around vLLM? Because I've attended a couple of sessions. I see there are a lot of folks who are attending. They're using it. They want to understand it bit because for few folks it's still a new thing, right? So how do you see the community growing around vLLM in India, outside India? What's your take on that?
Okay, so vLLM community is growing rapidly. I'll tell you one of the example is that we did one of the vLLM meetup in China, Shanghai. You'll not believe that meetup was attended live by 40,000 users.
40,000?
It was
online.
Oh
my God, that's good. That's a huge
there
number.
were 300 plus people in the hall.
Awesome.
In India specifically, we have been doing that and we see very good results.
Yep.
You just say that we are doing the vLLM inference because people will understand. There is a value because fine-tuning, that other things, that is there since long.
That's true.
But, and another thing is that India got a huge community of DevOps. Okay, DevOps people, they know the system.
Yes.
And when you introduce something which connects to the system, they're interested.
If you do, take it and implement.
So we see a lot of happening in the community base for the vLLM. There are the organizations like HP, Cisco, NextGen, or maybe what is that? NVIDIA. They want to join this community. And it's growing very fast.
Yeah, so I think I've seen that you have done this vLLM meetup in Bangalore a couple of months ago. Do you have any plan for the next meetup?
We are doing that in Pune. So I want to start this year meetup in Pune because Pune I see there is a lot of innovation happening. We want to collaborate with you.
Yeah, sure.
The NeevCloud is there. You are using the vLLM.
That's true.
We want to understand your experience. We want you to share your experience with the larger community.
Yeah. So I think thank you so much, Prasad, for giving us a high-level overview of what vLLM is, what the inferencing is, and what's the community building around it. Because we at NeevCloud also believe that open source is the future. And we spend a lot of our efforts into contributing to the community. So I was there in the DevCon also when we was talking about Kubeflow. I've talked to the engineering manager. We have said that we are going to commit at least 6 to 8 developers to Kubeflow because definitely there is something we are going to use in future. And I think vLLM, Kubeflow Trainer, there are a couple of other projects which are Red Hat is also contributing. So definitely that will be a good way of interacting with the community and using that to build a real life product. So thank you so much for your time, and we'll look forward to the
collaboration.
Thank you.
So I want to conclude this podcast saying that please join the vLLM community.
Sure.
Even if you are not into the GenAI space, if you are building the agentic application, there is a direct connection of the inferencing with agentic.
I see.
You will understand that, agentic, when we talk about the agentic, there is a lot of reasoning happening. The reasoning is something where you are generating more and more tokens. So it again comes to the inferencing. But in any of the area of the GenAI space, please join the vLLM.
Definitely. Sure. So I hope the audience found it useful, and thank you so much, guys.